Hello, everybody. We talk about how well the human can fly around in a solar system. Getting out of solar system is kind of out of question with current technology, but within a solar system, how freely can fly around with the current technology? Look at the current technology. See, the three stage rocket the NASA can create, the largest rocket to go to the moon. So what's happened is, say you have Earth's gravity and go to the moon. This is the moon. The first stage energy is used to launch to the low orbit. So from low orbit, second stage bring it up to the high orbit. High orbit is like those stationary satellite, synchronous satellite. It's about 40 kilometer high, and from there you make a journey to the moon, and about 2 days. This is kind of the time it takes for China and NASA to go to the moon. Well, India and the other takes about 1 month, and I will tell you the reason why in the section of navigation system problem. The 2 days, so Earth to moon is about 380 miles, right? Okay, so 2 days you calculate the speed. The average speed is like Mach 5, and this is just right because when it's getting to the moon orbit, lower orbit, this orbit speed about 5 Mach 5. Okay, the orbit distance r and centripetal force has this kind of relationship. Speed and r equals gravity mm r square. So you take this one, actually r v square is constant. So the if you make a distance 4 times r, then speed can be half since it's constant, right? So speed and orbit radius is related. This is a relationship, regardless the weight of the spaceship. So when you go to far away like a Jupiter, the speed is much slower because r is very big. Okay, so that's a relationship. The entry speed is about Mach 5, so average speed going to the moon is Mach 5 is just right, because if you go faster like a Mach 10, then you have to deaccelerate. Otherwise, when you come to the moon, it's going to overshoot and become elliptic orbit, and you have to correct that before you try to land the moon. Okay, so you can't go too fast. but you cannot go too slow either, because too slow, that means you have to enter at a higher orbit. Then you have to adjust the orbit again to get closer before you land on the moon. Okay, so just about Mach 5 is the average speed and entry speed to the moon. This is kind of just right, and that can be done by 3-stage largest rocket NASA can make. Okay, now we talk about C. What kind of energy level we need to fly around in the solar system, right? So suppose this is sun here, and Earth is about 90 million miles away, and the Mercury, Venus is somewhere around here. Okay, and Mars is about 1.5 times far away. Okay, and Jupiter is around let's see, 3 times, yeah, three times the Mars. So 1, 2, 3. This is Jupiter. Okay, and the Saturn is double it. So here's the Saturn. Okay, and Uranus is even double this. Here Uranus, and Neptune is somewhere around 1.5 times more here. Okay, this is a Neptune, and Pluto is very far away, 3.670 million miles. Neptune is only 2.8 million miles. So Pluto is so far away. It's out of sight. That's why when they find a Pluto, they didn't know if it's still going around Sun. Yes, there is a gravity acting even this distance, 3,670 million miles away. It's just solar cell, the potential energy level go all the way to Neptune and continue to the Pluto all the way. Now, what this means is, within solar system, there is always sun's gravity acting on it. Without sun's gravity acting on it, it won't go around the sun, right? It's far away. So this, you can say, the gravity potential well, and the humans is trapped here. The Earth is here, and before you get out of Earth, you have to get out of Earth's own potential well. You have to spend energy by rocket and get into this level, which is much smaller effect of the Earth's gravity. Then you can go to the moon or Mars. Okay, so we are talking about energy needed to fly around. So you learn the Newton's first law. If you push something, then it keep moving, right? Right? If you push something, it keep moving unless there's other force acting on it. and anywhere you go, sun's gravity is always acting this way. So in another word, on the earth, you throw something to the sky, it's fall down. You push something in this solar system, it will go back to the sun. Okay, according to this distance, the energy level, the image. This is initial speed v. You push at the initial speed v and go certain amount of higher level energy, but up to here, this is like you have a slope and you push the cart, initial v, right? Then cart go up and come back. So anything you throw into the solar system, it will come back to sun. So how can you go to the Jupiter? The Jupiter and Saturn is this far. Jupiter is 483 million miles. Saturn is 889 million miles. Okay, Earth is 92 million miles from Sun. This is a distance. Okay, so this much energy level exists. So suppose like when you go to the moon, you bring it to the upper orbit and use the engine to accelerate Mach 5. So you're flying to the moon. But the Earth's gravity pull, so you have to keep burning engine until you reach to the midpoint of the gravity between Earth and the moon. From there, you have to use the engine again because the moon gravity start pulling and increase from Mach 5, and you don't want to go too fast. You want to keep 5 miles speed to enter into the orbit. So you have to reduce the speed against the moon's gravity. So you have to do that speed adjustment. And largest, the largest rocket NASA can make can do this 5 miles, not 5 miles, Mach 5 speed to go to the moon. And now we know we can go to Mars, which need a little bit more, but you don't want to go too fast, but you have to keep going, so you have to keep burning fuel. So you carry the fuel, that means you are heavier to push forward, so you have to burn more. You keep burning in order to reach to Mars. Okay, so how much energy do you need to reach to the Mars? We know there is a asteroid belt, a lot of rocks between Jupiter and Mars, right? And occasionally some rock come to the sun and swing around and go back. Okay, so if you know this speed, the speed at around Earth, then you know this is the initial speed v to go up to around here, middle of Mars and Jupiter. And this speed, various asteroid speed, it shows Mach 20. So it's quite fast in order to shoot up and reach to somewhere between Mars and Jupiter. And that means this speed, when the rocket cannot produce Mach 20, there's no way you can reach in the asteroid zone. Okay. Now, comet Halley. That one come to the Earth, the Sun, and swing back. Where does it go? It's go somewhere around Saturn. This comet come somewhere around the Saturn. Okay, so that speed is like a Mach 140. So initial speed, if you have a Mach 140, you can go all the way, and it's come back around Saturn. Okay. So there is another one called Kuiper Belt. The Neptune, somewhere on the Neptune. Kuiper Belt is around here. So if one of rock come from here, it's going to accelerate all the way and shoot back. So this initial speed from Earth, this is Earth line, initial speed can go 250, Mach 250, or even more. Okay, that's the measured speed we know. That kind of speed asteroid and the comet are going around us, Earth. That means from us you need this much speed in order to reach there. This Saturn, you need at least 140 from the comet Halley. The 140 to 200, Mach 100 to 100, 200, 140 to 200 speed, initial speed you need. So that means whatever the traveling vehicles, spaceships weight, and v square this much energy is needed. And if you do calculation, if this is 200, Mach 200, it's a huge energy you need to shoot up. And there's no rocket the human can make to such a rocket right now in the technology. That means the current technology, we cannot even go to Saturn, the Mars, and we know Chinese one observation satellite went to asteroid belt and took the picture of asteroid and it came back. So up to here we know we can do, but beyond that, Jupiter and Saturn is questionable. What kind of rocket we need, because you need such a, the large initial energy to shoot it up, and whatever you throw in the sky, it's come back to the sun. This is sun sky. The 3-stage rocket, the first 2 stages are consumed to get out of Earth's gravity. So we're talking about after you get out of the Earth's gravity, using all the fuel in stage 1, stage 2 in the rocket, and stage 3 rocket has remaining fuel, and this fuel has to produce like Mach 200 speed, which cannot be done. Okay, there is a hope that there is a engine. If you have a infinite amount of energy has no mass, no weight, but energy can produce microwave, and microwave can push spaceship forward. And so far the experiment shows very minor force you can generate, but it's possible if this engine improve, then using nuclear energy engine to produce microwave and microwave push, and that's a way you don't need any fuel. The fuel has mass and you have to carry, and it's depleted, it's used up after even less than 1 year of engine burning. It's just all gone. So there's no way you can keep pushing it. That means same thing as throwing a rock in the sky, it come back to the earth. You throw the rock to the space solar system, it's come back to the sun. And this is the physics, and there's no such a thing like if you push it out, the probe just keep flying all the way forever. This is like a Star Trek fantasy. There's no such a thing. It's always come back to the sun by gravity, and you need that much energy, certain amount of energy, to reach the outer part of the solar system. And when it's come to this Pluto, it's almost impossible. See, we didn't know sun's gravity is extending that far, 3,670 million miles. Somehow you reach that place, it's still sun is pulling you back to the sun. Okay, so there's no way to escape solar system. Human is trapped in the solar system until technology improve. Don't know how long it's going to take. It may take another 1,000 years. Then it's possible to get out of solar system and go to different solar system 2, number 2 we can visit. Or there are so many solar systems within one galaxy. Getting out of galaxies, it may take another 5,000 years of technology. And then between galaxy, you're floating in the space, then you can do Newton's laws experiment. You push or it's keep moving. There's no other gravity. But there are multiple galaxies around, they try to pull you in, right? So there's no such a thing. This is a very ideal case that if you push, it keep moving if there's no other force exerted on it. That means there's no such a place in the space that it's just keep moving. Okay? Everything pulled by gravity, and sun is pulling everything within. This is the master of the solar system, and whatever you have a speed, you can reach to certain distance and pull back to sun. And that's the way the humans need to look at the solar system. We are trapped in this slope. We're living in this slope. And beside this slope, the Earth has its own slope here. And getting out of Earth's gravity is a big deal. We need already very big rocket. And after getting out of Earth's gravity, you are dealing with sun's gravity now. Okay? and Jupiter, even asteroid need Mach 20. Mach 20 is possible if you keep burning all the fuel you have and increase the speed to 20. You may reach to the asteroid belt, but the Jupiter is more energy, and there's no such a thing that, okay, we shoot the probe into the sky, it just keep flying for next 10-20 years. There's no such a things. It's sun's gravity always pull you back. Okay, so this is the right picture how you look at the solar system, and you know how far you can fly out of Earth. Get out of Earth's gravity, then you start flying. You need Mach 150 or so, or 250 to reach the satellite, and there's no such a engine or rocket right now the human has. Without that rocket, the physics tells you you can never go to Jupiter, you can never go to Saturn. Okay, so if they show the picture, oh, this is Saturn ring, the probe send the image, yeah, that's good, that's Hollywood. Okay, so see you next time.